Hi and welcome to Maths and Statistics class. In this particular session, I'll be dealing with probability and we'll focus only on simple probabilities. There is another video on probability distributions, both binomial and Poisson, even normal distribution. So you have a separate video on binomial distribution and Poisson distributions. Then you also have another video on normal distribution. So depending on the syllabus that you are doing, whether you're doing the CA 1.2, if you are doing CA 1.2, you just need simple probabilities and normal distribution probabilities. So get that video as well. But if you are doing DA2, you need all the three videos: the video on binomial and Poisson, the video on normal distribution, including this video. You need all of them. You need the three of them. So let's go into the details and look at probability, simple probabilities. Let's define what probability is. Probability is defined as the measure of likelihood. Probability is defined as the measure of likelihood. It's the way we try to measure the possibilities of certain things happening or possibilities of events happening. So it's a measure of chances. And this is very important for decision makers because we make decisions in the environment of uncertainty, and we need to have a way of trying to have a picture of what we should expect to happen in the future. So probability is simply measuring those chances of those events coming to pass. Probability ranges from 0 to 1. So any probability value that you calculate must be a value between 0 and 1. When the probability is 0, it means that the event is impossible. That event cannot happen. When the probability is 1, it means the event is certain. You are sure that that event will come to pass or it will happen. Expressing probabilities, we usually express probabilities in proportions rather than in percentages. Again, this has to do with how the question is phrased. If the question says calculate the percentage of this happening, you express your answer in percentages. Otherwise, generally probabilities are expressed as proportions. So if the probability is a 95%, you would rather write it as 0.95%. Now, the actual probability measure is calculated as the number of ways you can have a desired result over the total number of possible outcomes. Number of ways you can have the desired result over the total number of possible outcomes. For example, you toss a coin. A coin has only two sides, so the total number of possible outcomes is 2. What's the probability that you're going to have the head? If you toss the coin, there is only one way you can have the head out of the 2 possible number of outcomes for tossing a coin. So probability of having a head when you toss the coin is going to be 1 over 2. Let's look at another illustration. Suppose you roll a dice. What's the probability that a 6 will appear when you roll a dice? You see, a dice has got 6 sides that are numbered from 1 to 6. But there is only one way you can have 6 appear in a dice when you roll a dice. So the probability of having a 6 when you roll a dice is 1. There is only one way you can have 6 out of the total number of possible outcomes, which is the 6 sides of the dice. Having said that, now let's go into the next part. The next part, we are looking at probability rules. Now, I should emphasize that probability rules are very, very important. If you want to get comfortable dealing with simple probabilities, then you must understand the rules, because simple probabilities are based purely on probability rules. So let's see what these rules are. Rule number 1. Probability rule number 1 is a simple addition rule. It states that if you have a probability of A or B, the answer to that should be take the probability of A had to eat the probability of B. So probability of A or B equals probability of A plus the probability of B. The biggest question here is, when should we apply this rule? When should we apply this rule? At what point is this rule applied? This rule is applied when you have mutual events. So it's a rule we use for mutual events. Mutual events. So we apply the simple addition rule for mutual events. So what are these mutual events? Mutual events, these are events that cannot happen at the same time. These are events that cannot occur at the same time. Events that cannot happen at the same time. Events that cannot happen at the same time. Now let's give some examples of events that cannot happen at the same time. You cannot be seated and standing at the same time. It's not possible. When you toss a coin, either you have the head or you have the tail. You can't have both at the same time. Either you pass the exam or you have failed the exam. You can't pass and fail the same exam paper in the same exam sitting. It's not possible. So such events are described as mutual events, events that cannot occur at the same time, and we apply a simple addition rule for such events. Let's move on to rule number 2. Probability rule number 2 is the simple multiplication rule. Simple multiplication rule. The rule states that probability of A and B equals to probability of A multiplied by probability of B. So when you have probability of A and B, you have to multiply the two probabilities to get the actual answer. Again, the question still remains, when should we apply this rule? When should we apply this rule? This rule is applied when the events are independent. So these are for independent events. These are for independent events. So what are independent events? Independent events are events that can happen at the same time. The occurrence of one event does not cancel the possibilities of the other event occurring. In mutual events, the occurrence of one event cancels the possibilities of the other event occurring. In independent events, the occurrence of one event does not cancel the possibilities of the other event occurring. For example, you can be seated and talking. Those are independent events. You can pass two exam sittings or exam papers in the same exam sitting. For example, passing economics does not cancel your chances of passing mathematics. So you can sit for economics and sit for mathematics in the same exam sitting and pass both papers, because the fact that you passed economics does not cancel the chances of you passing mathematics. So these are events that can happen at the same time. Events that can happen at the same time. Obviously, you can add more examples to such events. Let's move on to rule number 3. Rule number 3 is called the general rule of addition. The general rule of addition. Now, the general rule of addition says that probability of A or B, probability of A or B equals to probability of A plus probability of B minus probability of A and B. All right. So, at what point should we apply this rule? At what point should we apply this rule? This rule is applied for independent events. This rule is applied for independent events. I've already explained what independent events are. These are events that can happen at the same time. So, if you look at the way this rule, general rule of addition, is expressed, it is probability of A or B. the addition rule, simple addition rule, look at the way it is expressed. It's also the probability of A or B. So what makes the difference here? Probability of A or B, where event A and event B are mutual events. You apply the simple addition rule. Probability of A or B, where event A and event B are independent. You apply the general rule of addition. That's what it means there. Last rule of probability, it's the general rule of multiplication. The general rule of multiplication. It says the probability of A and B equals to the probability of A multiplied by the probability of B given A as already occurred, equals to probability of B multiplied by probability of A given B as already occurred. That's the general rule of multiplication. Now here is a point. At what point should we apply this rule? This rule is applied when the events are dependent. When you have dependent events. The rule is applied when you have dependent events. So this is for dependent or conditional events. Dependent or conditional events. So what are these dependent or conditional events? Dependent or conditional events, these are events whose occurrence depends on the occurrence of the other event. Events whose occurrence depends on the occurrence of the other event. Events whose occurrence depends on the occurrence of the other event. Those are conditional events. Those are conditional events whose occurrence depends on the occurrence of the other event. So, let me just explain a little bit more on this one to just make it clear. Probability of A and B, where A and B are dependent events. The occurrence of one event depends on the occurrence of the other. Is equals to probability of A multiplied by probability of B given A has already occurred, also equals to probability of B multiplied by probability of A given B has already occurred. So, for instance, if you want to make probability of A given B has already occurred using these two parts of the expression, by making that the subject of the formula, you will divide both sides by probability of B. So this is how it will turn out to be. Probability of A given B has already occurred will be probability of A multiplied by probability of B given A has already occurred, which is this part here, divided by probability of B, which is that part there. I think you know how to do the subject of the formula. Now, probability of A multiplied by probability of B given A has already occurred. It's expressed that this is also the same as probability of A and B. So the same expression can be written as probability of A and B over probability of B. Finally, this part, let me look at expected values. What are expected values? Expected value is simply the value multiplied by its corresponding probability. Value multiplied by its corresponding probability. And the expected value of a probability distribution, expected value of a probability distribution is the mean of that probability distribution. The mean, it's also called the mean of a probability distribution. So to get the mean of the probability distribution, you get the summation of x multiplied by their corresponding probabilities. Now I want just to look at few examples, just few examples in this session, because we have our revision sessions that we have to conduct, intensive revision sessions that we are going to do. So in this session, I will just look at few examples from the CA 1.2 final exam for December 2017. December 2017. There we are. So that's December 2017 CA 1.2 paper. So let's check what we can look at from this question paper. Starting with 1.1, it's coming from probabilities. 1.1. It says the probability that an event will occur is the value that ranges between what and what. So this is the probability range. I just mentioned that probability ranges from 0 to 1. 0 to 1, not 0 and above 1. Because if you say 0 and above 1, the above 1 can be 100. It's only from 0 to 1. So the correct option there is option A. Let's move on to section B and look at question 4C. Section B, question 4C is a question on probability as well. Question 4C, section B. Okay, so there we are, question 4. Now, question 4 is a big question. It's a combination of statistics and probabilities. And when the examiners combine questions like this, sometimes it can be confusing for students. Here is the key. You have to identify the parts for statistics and identify the parts for probability. If you can't separate those parts, you'll find that the question might be a little bit confusing. But if you are an expert, of course, if you have practiced a lot of questions, you will discover that dealing with a question like this is quite easy. All right, so it says the research unit of the University of Zambia collected the following data of sales made by 69 SMEs for the last quarter of the year. So the data is given, and it says during the year 2016, the research unit of the University of Zambia experienced the high demand for data analysis. In order to cope up with this demand, the university advertised the position of data analyst. 100 individuals. So now when you come to this other part, it clearly shows that this other part is going to be a probability part. So 100 students applied for the position. Of 100 students who applied for that analyst position, 40 had some prior work experience and 30 had professional certificates. However, 20 of the applicants had both work experience and a certificate, and thus are included in both figures. So what that statement means is that the 20 is included in the 40, the 20 is also included in the 30. So 20 is more like an intersection set. It's a group of applicants that belongs to both groups. So when we count 40, we also have the 20 that has got both. When we count 30, there we also have the 20 that has got both work experience and certificate. The last paragraph there says the University of Zambia intends to sell 3 of its computers in order to replace them with latest and fast data processing ones. The probability of selling each computer is probability of S equals to 0.3. Again, that part is for probability. That part is for probability. So we have the last 2 parts for probability, the first part for statistics. So if the probability of selling is 0.3, then the probability of not selling should be 0.7, because you either sell or you don't sell. So between selling and not selling, those are mutual events. Those are mutual events. All right, so let's go to the part. Part A says SME, calculate the mean, that's statistics. Okay, part 2, explain how to do that, that's statistics. So part 3 or part C, it says suppose of the 100 individuals who applied for the position of data analyst, W represents individuals with work experience, C represents the individuals with professional certificates. Calculate the probability that a randomly selected applicant had either work experience or certificate. Now, when you look at a question like that, what should come in your mind first are the probability rules. So what probability rules talks about A or B? We are using A or B. So we have two probability rules that talks about A or B. The simple addition rule, we apply A or B, we apply the simple addition rule if those two events are mutual events. So what are mutual events? Events that cannot happen at the same time. So if you look at work experience and having a certificate, are they mutual events? The answer is no. You can have work experience and a certificate. You can have both. Actually, the question indicates that you can have both. The fact that you have a certificate, professional certificate, does not disqualify you from having work experience, vice versa. So these are not mutual events. These are independent events. And if they are independent events, we are going to apply the general rule of addition. So let's see how we can work out a question like this. Let me just pick this question and take it to our answer page. Okay, so we take it there. Okay, so let's get first things first there as part of our solution. First, we have 100 students in total, so number of people or elements, that's 100. Probability of W is the number of those who have work experience. So probability of W, number of those who have work experience out of the total number of candidates there. So probability of W is going to be so we are told that 40 have work experience out of 100. So that probability of W is a 0.4. Let's look at the probability of professional certificate. Probability of having a professional certificate. Say, let's see, represent professional certificate. That number is 30. So 30 out of 100 have professional certificates. 30 out of 100 have professional certificates. So there the number is 30 out of 100. And obviously that gives us a probability 0.3. And finally, those who have both, which is the probability of W and, you can use N for and, W and C. That probability, we are told, it's about 20 people that have got both, 20 candidates have both certificates and work experience. And that's what makes these independent events, because the fact that you've got a certificate does not disqualify you from having work experience. So that's 20 out of a number 100, and that probability is going to be a 0.2. Now, what the question is asking is calculate the probability that a randomly selected applicant had either work experience or certificate. So you're looking at the probability of W or C. W or C. That's a probability that you're looking at. Now, W or C. Now, in our explanation on probability rules, we had used A and B. So let me just take you back there and you'll see what I'm talking about. These events are independent events. So how can we apply those rules? Now, you have the first rule, you have A or B, where you have to add the probability of A and add the probability of B. But this one, you can only do that if the events are mutual, if the events cannot happen at the same time. We also have, on the third rule, general rule of addition, we have A or B. You can do that if the events are independent. And the case we have here is the case of independent events. So we apply the general rule of addition, where we say probability of W plus probability of C then minus the probability of W and C. That's quite easy. So this will be probability of W, we've already expressed that, that's 0.4, plus probability of C, that's 0.3, minus probability of W intersection C, which is a 0.2. So put those figures together, it will give you 0.5. So probability of W or C, the answer will be 0.5. 0.5. All right, now let's move on to the next one. I think that was part one of the solution. That was part one of the solution. Let's try to look at part two of the question. Let's go back to the question and see what the next question is. Okay, so that part done. Part two of the question says, the probability that a randomly selected applicant had only work experience, but not professional certificate. We know that those who have work experience, they were 40, and those who had both were 20. The 20 that had both had been counted in the 40. So obviously this is quite straightforward. Probability of those who have work experience only, you do the total number of work experience minus those who have both. So let's take it back to our answer sheet and see how you are supposed to deal with a question like this. Okay, so since the probability of W is 0.4, and the probability of both is 0.2, so you say 0.4 minus 0.2, it will give you the probability of W only. So probability of W only is going to be equals to 0.4, which is the probability of W, total W, then minus the probability of those who have certificates in W. So minus 0.2, those who have both. So this is gonna be 0.2. 0.2. Done. Okay, so that's how you're supposed to handle those probability questions. Let me try to look at another probability question. Wow, there is the part that we have left out, the part of selling computers. Let's go back to the question and just look at it as well. Actually, that is reflected in part D of the question. Using the probability of selling each computer given in the scenario above, calculate the following probabilities. So the probability of selling a computer given in the scenario, we saw that it's there. Probability of selling a computer, that's a 0.3. So probability of not selling computer, it is going to be 0.7. So let's get back to the question. We pick the question, we take it to the answer page, and we see how you can handle a question like this. Okay, so this has two parts. There are two parts to this question. So the first part is there, and then the second part is here. So let's create space there. So what's the probability that exactly two properties were sold? We are told that the university wants to sell 3 computers, so there is only 3. Our sample size is 3, n is 3. So what's the probability of selling 2? So probability of selling 2, you sell the first one, you sell the second one, and then you fail to sell the third one. Now, are these probabilities, are these events independent, or they are mutual events, or they are conditional events? The fact that you sell the first computer does not influence how you're going to sell the second computer. So these are independent events. Between selling the first computer, second computer, and the third computer are independent events. Independent events are events that can happen at the same time. The occurrence of one event does not cancel the possibilities of the other event occurring. So the fact that you sold the first computer does not cancel the possibilities of you selling the second computer. So these are independent events. And independent events, we apply the simple multiplication rule. The simple multiplication rule. So this is how your probability calculations will be. Simple multiplication rule, probability of selling exactly 2. So x is equals to 2. Probability of x equals to 2. That is going to be equals the probability of selling your first computer multiplied by the probability of selling the second computer multiplied by the probability of not selling the third computer. So the third one is not sold. And so calculating that, this will be a 0.3. Probability of selling a computer is 0.3 multiplied by 0.3 multiplied by the probability of not selling the third one, which is 0.7. So when you multiply 0.3 by 0.3 by 0.7, you should get 0.063. Use your calculator to do that. 0.063. 0.063. So the probability of selling 2 computers out of 3 computers is 0.06. What I want you to pay attention to is not necessarily how you're calculating this. It's understanding the rules. When you understand the events, you know the rules to apply. Simple probabilities are all based on rules. If you get confused with the rules, you'll find this type of probabilities to be very difficult for you. So I encourage you, understand the rules. If you don't understand the rules, please go back to that part of the rules and listen until you ensure that you understand those rules. That's what's gonna help. All right, so let's deal with the last one, probability that at least 2 computers will be sold. At least 2 properties are sold. So at least 2, either you sell 2 or you sell more than 2. Either you sell 2 or you sell more than 2. So probability of at least 2, you have your probability. And here x will be greater or equal to 2. X will be greater or equal to 2. X greater or equal to 2. Alright, so the probability of selling 2 and the probability of selling 3. So between the probability of selling 2 and the probability of selling 3, what type of events are those? These are mutual events. Either you sell 2 computers or you sell 3 computers. You can't sell 2 computers and you sell 3 computers at the same time. You either sell 2 or you sell 3. So those are mutual events. So what rule are you going to apply? The simple addition rule. So it will be the probability of selling, and not selling the last one. That's the probability of selling 2. We've already calculated that. Or you have a situation where you sell all the 3. So the probability of selling, and selling the third one. So this is going to be equals to, you know, these are 2 parts are mutual events, so you use the simple addition. This one, SS not selling, we've already calculated that figure. It was 0.063. So that will be plus. Why are we adding? Because they are mutual events and we are applying the simple addition rule. Then the probability of selling all the 3 is selling the first one, selling the second, selling the third one. So 0.3 times 0.3 times 0.3, that's going to give you 0.027. 0.027. When you put those figures together, you should get a 0.09. That's the probability of selling at least 2 computers. Selling at least 2 computers. So because we have, we are going to go through these question papers in our revision sessions. We'll go through the full question papers. I just wanted to give you a few of this probability part. It was the only part that was remaining, and we start our revisions. So thank you for your time. Please make sure you understand these probabilities.